Hey, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in this video tutorial, we're going to take an introduction to the three different types of expressions, that is infix, prefix and postfix. Now this topic comes under the application of stack data structure. So if you've seen the stack data structure video, in the applications I told and mentioned that stack data structure is used to do the conversion between infix to prefix and postfix and vice versa. So let's understand what these three different expressions are, and this is a very important video because in the next few video tutorials we're going to see this infix, prefix and postfix quite a lot. We'll also see how the stack data structure is used to do the different conversions, the algorithm used, and why do we need it. But let's first understand and let's just take an introduction to what these expressions are, and more importantly, why do we need these expressions. Now if my voice is sounding a little different, I have cough and cold, but the video should go on, right? So with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Now starting off, let's first understand what exactly is an expression, okay? So I'll just quickly read through this theory. This is pretty self-explanatory. If you're making some notes, you can note them down, and I'll obviously be sharing some details in the video description. But an expression is a combination of symbols that can be numbers, constants, variables, operations, operators, symbols of grouping and other punctuations written in a specific format. Okay, so this specific format is what distinguishes between infix, prefix and postfix. So we'll see that in a minute. But typically an expression kind of looks like something like this. Let's say this is a plus b. So this is a mathematical expression. This is an arithmetic expression where a is a variable, right? B is also a variable, but this plus sign is an operator. Okay. So we have operand and operator. So these variables, that is a and b, are basically operands. So operand is an entity on which some operation is performed. Typically, an operand is a number, a variable or a constant, or it can also be an expression itself. For example, let me write another expression. We can have a plus b, then we have star, which is multiplication, and then we have, let's say, 5 plus 3. Okay. Now if you observe this expression, we have two operands over here. Let me write op and op for operand, and then we have one operator in between, right? But this entire part, left hand side, can be considered as one operand also, because then we also have an operator in between over here. So this is another operator, and similarly the same story goes for the right hand side. So this one entire thing can be considered as an operand. Internally we have two small operands also, and then we have an operator in between, right? So this was operand, and then the operator is basically the entity that decides which operation to be performed. For example, plus is for addition, we have star for multiplication, we have slash for division, we have minus for subtraction, and so on and so forth. So far what we saw is an expression which is kind of looking like this, where we have a, that is, let's say this is a variable, okay, then we have a plus sign in between, and then we have b, which is another variable. So this plus sign becomes the operator. Okay. Now of course it can be anything, like it can be a group of variables, it can be constants, it can be multiple operators and so on and so forth. But this format you can see is kind of looking like where there are two operands and then we have one center operator. So this is basically what we usually see as expressions in arithmetic. This is human readable and this is known as infix expression. So typically an infix expression looks something like this. We have operand over here on the left hand side and on the right hand side, and then at the center we have the operator. So an example would be a, then we have plus, and then over here let's say we have a constant 5. Another example can be something like this. So in this you can see this entire expression comprises of inner smaller expressions. So over here you have a star 5. So star is the operator and the two operands for this operator is a and 5. Similarly on the right hand side you can see we have three operands right? So we have 4 which is a constant, we have b which is a variable, and then we again have 3 which is a constant again, and then we have 2 operators in between. So when we have plus and minus, we go from left to right. I'll explain what this left to right is. So for this plus operator, we have the 2 operands as 4 and b, and for minus operator, then we will have whatever result we get from 4 and b would be then utilized over here, that is 3 would be subtracted from whatever we get from this. Okay, and then ultimately when we evaluate this bracket and this bracket, so whatever result we have, that is r1 and r2, that ultimately gets subtracted because we have one minus sign in between. So this is what infix expression is, where we have 2 operands on the left and right, and in the center we have the operator. Now these operands can be anything. It can be variables, it can be constants, it can also be smaller expressions just like this one, and the possibilities are limitless. Okay, so now that we've understood what is infix expression, let's see what is prefix and postfix, and then we'll also understand why we need them, because that's more important. So stay tuned for that, watch this video till the end, because at the end we'll discuss that as well. So in prefix expression, what happens is the operator comes before the 2 operands. Okay, so the example where we did a plus b in the infix one, so if a plus b is for the infix expression, for the prefix it would be something like plus a b. So this is how the same version of infix would look like in prefix. Okay, so we have plus, which is the operator, let me write it in green, and then we have a and b. Okay, so this is that expression. Now a complex expression, for example, let's say the expression is a plus b star c. Now in infix, that is in the arithmetic expressions that we usually solve, remember that whenever such expression comes where we have 2 different operators, we apply the concept of operator precedence, wherein multiplication happens before addition, right? So b star c should happen first, and then that should be added with a. Now when we are converting this to prefix, I'll just show it in rough right now. We take this smaller expression first because this is supposed to be evaluated first. So this operator will come before b and c, because for this star, the 2 operands are b and c. So it would be written like star bc, and then we have a plus and a. So now this entire expression becomes operand 1, and this becomes operand 2. So now again we have to take this plus ahead of this place to make it completely prefix. So we have plus a star bc. Okay, so this infix expression will look something like this in the prefix version. Now I'll explain to you in detail the conversion, and we'll see that in future videos also, but this was just to show you how it would look like in a prefix format. So we have plus a star bc. Okay, now we'll understand how we can do the conversions in between, but right now let's look at postfix also. So exactly opposite to prefix, in the postfix we have the 2 operands first, so we would have a and b, and then we have the operator plus. So a plus b in infix would look like ab plus in postfix. Okay, and again we'll see how the conversion would look like, but let's summarize these 3 different expressions and then we'll understand why we need them. So yeah, depending on how the expression is written, we can classify them into 3 categories. That's just what we saw. We have prefix, where expression is called prefix if the operator appears in the expression before the operands. So here's the prefix version of 2 plus 3. We have plus 2, 3. These both are constants. And similarly in postfix, expression is called postfix if the operator appears in the expression after the 2 operands. Now do note that in this video we are just talking about operators which are binary in nature, which means we have binary operations, that is the operator operates on 2 operands only. Now technically we can have operators that work on single operand or 3 operands also, but for this video we are looking at operators which are binary in nature, which means they operate on 2 operands only. Okay, so keep that in mind. So yeah, this is just a theory of what we just saw, so if you are making some note you can note them down. But now let's take a little bit more detailed look at evaluating a infix expression. Okay, so as you can see on the screen, we have an infix expression which is kind of simple. We have a plus b star c. Okay, now we need to evaluate this. When I say evaluate, we need to find out what the result would be. So let's assume a is 4 plus, let's say b is 5 star, which is multiplication, and let's say c is 3. Okay, so this was in variable format, this is now constants, and now we need to evaluate this. This is an infix expression where the operator is coming in between the two operands, and now we need to evaluate this. Now we know the mathematical principles where we have the concept of operator precedence. So here's the operator precedence. So very first comes parentheses, then we have exponents, then we have multiplication and division. So multiplication happens before division. From left to right, we'll talk about left to right and left to right over here, whatever there is written in the brackets. And lastly, we have addition and subtraction. So in our case, you can see that we have a plus operator and we have a star operator. Now according to operator precedence, you can see that multiplication and division is above addition and subtraction. So this number 1, number 2, number 3 and number 4 is the precedence values itself, which means number 1 is having higher precedence than number 2, number 2 is having higher precedence than number 3, and number 3 is having higher precedence than number 4. And what this precedence means is, if there are multiple operators from these different categories, the parentheses will be executed first or calculated or evaluated first, then the exponents will be evaluated. Exponents means something raised to the power something, so 2 raised to 2, which would be 4, or a raised to b and whatever. So these are exponents. After that, multiplication and division will be evaluated, and after that, addition and subtraction. So in our case, it's a simple example where we have a multiplication and then we also have a addition. Now according to operator precedence, multiplication comes before addition. So we know that 5 star 3 will happen first. So then let me just write it over here. We have 4 plus 5 star 3. So this expression will become 4 plus, obviously 5 star 3 will first happen. So 5 3s are 15. So this will be the result of 5 star 3. Then we will add 4 and then we will get 19. Okay, so this is one way to go about it. What if we wanted 4 plus 5 to happen first? So let me just write down the second use case, 4 plus 5 star 3. Now here, according to operator precedence, obviously 5 star 3 should happen first. But let's say I write 4 plus 5 in parentheses. Now if you see the operator precedence, parentheses happens first or comes before multiplication. So in this case, 4 plus 5 will happen first, so that would be 9, and then it would be multiplied by 3. So 9 3s are 27. So you can see in these two use cases, the output was different. That is, the result came different. And this is just because of operator precedence. Now another thing to keep in mind is associativity. So associativity describes the rule where operators with the same precedence appears in an expression. So let's take that example now. Now let's take another example. Let's say we have a minus c plus b. Okay, let's substitute these values, whatever we've considered for a, b and c. A is 4, so we say 4 minus what is c? C is 3, and we have plus b, which is 5. Okay, so according to associativity of addition and subtraction given in point number 4, we go from left to right. So we evaluate this expression from left to right. That's what associativity is about. But why do we have this? So according to the definition, associativity describes the rule where operators with the same precedence appears in an expression. For example, in expression a plus b minus c, both plus and minus have their same precedence, right? So they are at precedence 4. Both of them have same precedence value. So in that case, which part of the expression will be evaluated first is determined by associativity of those operators. And in this case, the associativity is from left to right. So let's take first use case. Let's go from left to right. In that case, we will do first 4 minus 3. 4 minus 3 is 1. Then we are left with 5. So 1 plus 5 is 6. Okay. Now let's take another or second use case where we have the same values, 4 minus 3 plus 5. And let's not follow this rule of associativity and let's go against it. So let's go from right to left. Okay, let's not follow the rule and let's see what we are getting. So in that case, we will do these two things. So 3 plus 5 we are going to do. We are not considering this as minus 3. We are considering this as positive 3 plus 5. So we are left with 4 minus, what is 3 plus 5? 8. And now if you do 4 minus 8, ultimately we will get minus 4. So you can see these two results are not matching. And this is why we require associativity. That is, we need to understand how to go about evaluating the expression if we have the same precedence. So we have multiple operators of the same precedence. So we need to always go from left to right, otherwise we will get some wrong results. So these are general rules that we have to follow when we have an infix expression. And now this actually takes us to the question of why do we need infix, prefix and postfix. Now we just saw how we are evaluating an infix expression. When I say evaluating, we just need to calculate the result of that expression. And in infix expression, you can see that we have so many rules and regulations to be followed. We have operator precedence, and inside operator precedence, if we have multiple operators with the same precedence, we also have to follow the rule of associativity and whatnot. So this is one drawback of infix expression, which is pretty much easy for us to calculate. But when it comes to machines, when it comes to computers, all these extra information of precedence and associativity makes the entire algorithms and calculations inefficient. So this is why we require prefix and postfix. So the question of why we need three different expressions and formats is, infix expressions are human readable. Yes, we can easily read a plus b rather than plus ab or ab plus. So this is more readable for humans, but it is not efficient for machine reading, because we just saw that, we have to follow the order of operators, we have operator precedence, we have associativity. So all these extra information makes the arithmetic calculations in, algorithmic process becomes a little inefficient. So prefix and postfix do not need the concept of precedence and associativity. Hence it becomes highly efficient to parse expressions in prefix or postfix. Okay. So why does this happen? Why does prefix and postfix do not need the concept of precedence? Now it is because these expressions are such, that is prefix and postfix are made in such a way that this precedence and associativity is never involved, because the position of the operator is always going to be fixed, which is going to be either to the end of the expression or at the start of the two operands. So let's just take the same example of, a plus b star c. Now this is an infix expression, and in this case the operator precedence has to be applied because star or multiplication happens first and then this happens second. So this information needs to be stored somewhere when you are evaluating this. But let's see this same expression in postfix format. So in postfix, what would happen? This star will come over here. So we would have b c star, and then we are left with a plus. So this plus will come over here. So we will have a, b, c star and plus. Okay. Now here, when we are evaluating this expression, we can easily go through this entire expression from left to right. We can see we have a, then we'll go over here, we have b and we have c. So we know the last two operands is b and c, and then we are getting an operator. So when we get an operator, we go to two operands back. We can see that b and c are the two operands which would involve with star. So when we are converting this back to an infix expression, we will say a. We just saw that star is having c and b just behind it, right? So we'll write b star c, and then once we go one more step ahead, we see plus. So for plus, b and c is operand 1, op1, and a is operand 2, op2. So plus comes over here, and ultimately we will get the infix format. So here we did not even need any kind of precedence or any kind of associativity. Simply the position of these operators were enough to determine which operation happens first and which operation happens later. Okay. If this is sounding a little confusing, as we move ahead in this course, we will see more conversions and more details about how we can convert infix to prefix to postfix and vice versa. Just note that prefix and postfix do not need the concept of precedence and associativity. Hence it is highly efficient because then we don't need to store any extra information when we are evaluating arithmetic calculations in different algorithms. In fact, postfix was specifically developed for arithmetic calculations done by computers in digital world, and hence whenever we do mathematical calculations, the infix expressions are first converted into either prefix or postfix, usually postfix more because the algorithm that convert infix to postfix is kind of straightforward and easy to understand, which we will see in further videos. But yeah, usually infix is human readable, which is converted to postfix before evaluating arithmetic expressions in the computer. So yeah, this was just an introduction to infix, prefix and postfix expressions, that is these different formats, and we understood each of them individually of how they look like, but more importantly we also understood why do we need these three different expressions and how is infix inefficient compared to prefix and postfix. Infix is more human readable but inefficient when it comes to arithmetic calculations done by computers, whereas prefix and postfix are much more preferred and highly efficient, and hence infix is usually converted to either prefix and postfix and is passed into these expressions before any kind of evaluation, and this conversion is usually done using a stacked data structure. Okay, so this is where in the next video tutorial we'll understand how a stacked data structure plays a vital role in the conversion of infix to prefix or infix to postfix and vice versa, and we'll see those different conversions wherein we are going to take the help of stacked data structure. So if you don't know what is stacked data structure, do check out this playlist. We have detailed explanation of what is stacked data structure and in fact also a program. So make sure you clear that concept first. So in the next video, we'll see more on infix, prefix and postfix and the conversions. So yeah, that's it for this video guys. I hope you understood the three different formats and why we need the different formats. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share it with your friends and I'll see you guys in the next video. Peace.